Hey guys, welcome back. This will be the second session of day 4. Here you are joining me on Friday, the week of Memorial Day, or Labor Day. And we've got EIGRP on the agenda. We'll go ahead and take a look at it today just with IPv4, and we will pick up on Monday looking at EIGRP implementations with IPv6. Whenever I teach the classes and I get to see students' faces, like in a live environment, I say, all right, I'm going to teach you guys OSPF on IP version 6. Everybody's like, no one's looking thrilled about it. They're just like, oh, here we go. Why? And they're like, I'll hear what he's got to say, but this isn't going to be pretty. And I think everyone's surprised by how easy it is to do the routing protocols in IPv6. We saw that with OSPF in ICND1. We said, here it is in IPv4. We used a lot of network statements. And in IP version 6, you just point at the interface and you go, that interface, that one right there, G00, we're going to do OSPF there, and it's going to go in area 1. And that's all you have to do. No network statements even. You just turn it on, give it a router ID, and tell which interfaces to run on. Really pretty easy. We're going to see that it's just that easy with the EIGRP. So let's start with IPv4 today, and we will kind of spread the pain a little bit by moving into EIGRP on IPv6 on Monday. So all right, looking at our agenda here, EIGRP simply stands for Enhanced Interior Gateway Routing Protocol. Now, a lot of people believe that this is Cisco proprietary. And if you were to pick up a printed book off the shelf, it would probably tell you that. But about a year ago, Cisco opened up EIGRP, and they said other people can run it if they want. So HP, Juniper, etc., Microsoft, Linux, they can do their own EIGRP implementations and tie into it. As far as we're concerned, how does EIGRP differ from OSPF? For the most part, OSPF is the more popular one, but not in a major way. It's, I would say, like I guess like a Ford and Chevy or a Mercedes and BMW. Sure, there's other cars that come from Europe, but I don't know. I think European car, Mercedes and BMW, then there's like all the other stuff, Ferraris and Volkswagens and Lamborghinis and etc. So sure, there's other cars in America, but I tend to just think Ford and Chevy. And if you're like something else, ignore me. I don't mean to forget the number 3 that you think is a number 2. That's totally all right. You get the idea though. EIGRP and OSPF are not exactly neck and neck. OSPF is going to be more popular. And more people run it, I would say, because they don't want to be tied to a particular vendor. They don't want to change their mind and hate Cisco in the future and then have to change their whole routing protocol. So looking at the two, EIGRP is now a standard, but it'll probably take some time to have it kind of approach like a 50-50 stance. I think more people may start running it because it's standardized, but still waiting for the support to come out from the other vendors. So besides the, I guess you could say, logistical aspects of it, what do we need to know about it? Well, it's a dynamic routing protocol, very much like OSPF or RIP or BGP, and it has the same purposes: discover remote networks, maintain up-to-date routing information, calculate the best path. The way that OSPF calculates the best path is based on bandwidth and bandwidth alone. And remember, it uses that default reference bandwidth of 100 megabits per second. So out of the box, you have to change the reference bandwidth for OSPF, or 100 meg links, gig links, 10 gig links, 40 gig links, 100 gig links, all have a cost of 1, so it doesn't make very good forwarding decisions. When we look at EIGRP, it uses a little bit more complex metric, and it also looks at bandwidth, but it can also look at delay. So is there a bunch of latency on the link? If so, let's not use it. It combines these into a little bit more advanced metric, and it makes a better informed decision. So who's capable of choosing the best path? Honestly, I would say EIGRP, first and foremost because it's not broken right out of the box. Second, because it's looking at bandwidth and delay, where OSPF is just looking at bandwidth. Additionally, whenever EIGRP comes up with a best path, it goes, while we're going through all these routing entries and we're processing all these complex metrics, is there a second path that's not going to get me into a loop? I need to be smart enough to know that this isn't going through some path that I'm already using in a loop, but is there a second path that's legitimate? If so, I'm going to keep that as a backup. I mean, I've got all this information in front of me. I'm thinking about it right now. I'm going to pen down what is my best path. And should that fail, I want to know what my second best path is. So In the event of a failure, if I lose my primary path, I've got a hot standby ready to go. So I can immediately recover from a failure. And this is why they say that EIGRP has faster convergence than any other routing protocol. So in terms of comparison to OSPF, it's got a better metric. It's faster to converge, but historically it's been proprietary. Going forwards, it won't be anymore. This final statement won't have a lot of meaning. Maybe it will, but it might not. And then later in life, as you learn more and you experience more and see more, it'll make more sense. But OSPF, when you perform summarization, it can only be done between areas. So with OSPF, we have to construct an area, which is a bunch of routers that are going to work together. Then we have an ABR, that's an area border router, that connects us to another area, and that's where summarization is performed. We've got to be really careful with summarization and do good summarization to minimize the number of routes. Not because we want a small routing table, but because we want to keep our LSDB small, and we want to isolate ourselves from changes in another area. If some /30 or /28 goes away, and I'm 2 areas away from them, I don't want to know about it. So you've got to do good summarization OSPF to make it manageable. EIGRP, on the other hand, doesn't really need that. It's good if you have hierarchical addressing. It's ideal. But if your addressing is pretty screwed up, EIGRP is a little bit more lenient about the way that it lets you perform summarization and the results of a non-summarized environment. So it's a little bit... it operates a little bit more easily in a network that's a little bit more of a mess. That might be a polite way to say it. So if it's so good, why isn't it so popular? And again, it's just because the vendor lock-in. I would say across all the students that I see, it's somewhere between like a 60-40 to 70-30 ratio, with the majority of people running OSPF and the fewer number running EIGRP. So that's some of the details about the routing protocol itself and what it is and why it is the way that it is. In terms of routing protocols, they could be classified as IGPs versus EGPs. Does anybody remember those acronyms? It's Interior Gateway Protocol versus Exterior. These are really categories where RIP, EIGRP, OSPF, ISIS, on-demand routing, the old classic ODR, those all fall under IGP. An EGP is what runs outside of your gateway. Exterior Gateway Protocol. Well, there's only one routing protocol in this category, and that's BGP, which is a routing protocol of the internet. Routing protocols can be classified as distance vector, which is how far and in which direction, also known as routing by rumor because we form links with and exchange information with directly connected neighbors. Link state, which is what OSPF falls under, is going to send out link state advertisements to everyone in the area. So if you get a routing update, you get it from the other router, not from your directly attached neighbor. RIP is distance vector, and they say that EIGRP is an advanced hybrid. It literally is. If we look at EIGRP, he borrows some properties literally from BGP, he borrows some properties from OSPF, and he borrows some properties from RIP. So they looked at how all the other protocols worked, and they decided to do things a little bit differently with this one. So sometimes classified as advanced distance vector, sometimes they just call it a hybrid. BGP is classified as path vector, which is really kind of basically distance vector. And EIGRP fits somewhere in the middle. When they describe something as being classless versus class full only advertises a network without the subnet mask. So if you hear about the 10 network, it's the whole 10/8. You don't get subnet mask information included with it. Older routing protocols were classified as classful. That doesn't really work today. So today, all of our routing protocols support classless. With our routing protocols, remember that each routing protocol has an administrative distance assigned to it. The administrative distance just defines in a tie if I hear about, let's say, the 10.330 network, and I get advertised a value in OSPF, it says your cost is 20. And EIGRP comes over and he says your cost is 317629571. I go, man, that is an ugly cost or an ugly metric. It's not as easy to look at and calculate the way that OSPF is. But regardless of these two numbers, you might as well interpret these as this guy telling you how far something away is in, let's say, inches. He says, this is how many inches it is to the airport. And this guy's telling you, this is about how many minutes it's going to take you to get to the airport. Well, I can't look at minutes and I can't look at inches and compare between the two because they're totally unrelated. But I'm being told by two different parties in two different languages, the fastest way to get to the airport is over here. Because they don't have compatible metrics or cost to do comparisons between, we rely on the administrative distance. I go, somebody tells me how to get to the airport, or in other words, the 10330 network, if they tell me an EIGRP, I'm going to believe that because I feel that it's a better routing protocol. In other words, Cisco chooses Cisco over open source. And that's just because it's a more advanced, a more complicated metric. And in the events of a failure, this isn't an opinion, it's a fact. This will be faster to reconverge, unless your network is broken and you run into some complication. But if they're both configured properly, EIGRP is going to converge much faster. And it's because he sets up a backup route right away. And if the primary fails, he doesn't need to go through link state changes, link state updates, updating a database, reprocessing a database. EIGRP has got his new route good to go. It's sitting there waiting. So in other words, just to kind of put this in summary, EIGRP has a lower administrative distance. So if you're learning routes through EIGRP and you happen to learn the same exact prefix, 10330/24, if you learn it through EIGRP and you learn it from OSPF and you learn it from RIP, who is it going to believe? EIGRP. And then second most preferred would be OSPF, and then third most preferred would be RIP. Is everybody okay with that? Because you've got different administrative distances. Good. I appreciate the thumbs up. Thanks, guys. So some of the features, like I said before, he creates a backup route, so he's going to be the fastest to converge. He can support load balancing. So if he's got two paths to get to a destination and they've got the same cost, we can use both paths. He guarantees loop-free, classless routing. So we're not going to create routing loops, and we support subnet masks. We can use less bandwidth than something like RIP. We can bundle together lots of updates at once, and we don't broadcast the way RIP version 1 did, which is why we don't use RIP version 1 anymore. You'd use RIP version 2, which does multicast. The way that path selection works is based on the bandwidth and the delay. We calculate a metric. Think of this as the same thing as cost in OSPF. When you look at different paths, the path with the lower metric is going to be the one that's preferred. So when I learn about a destination, they say the cost to get to the 10110 network is 1,000. So the way that this works is a router, a neighbor, let's call these guys R1 and R2. Routers advertise distance to one another. So they say, hey, I can get to the 10110 network, and the metric there is 1,000. Well, when I hear that, I have to ask myself, well, how long is it going to take me to get to that neighbor? And if the cost to get to the neighbor is 1,000, then the actual distance is going to be 2,000. Does that make sense? The analogy that I give to people, and let me show you a map of Florida because I base my story on Florida geography. And I don't know every city, and you may not know my city, so let me just show you what I'm talking about here. If you came to visit Florida, and I was working downtown in the data center, right here where it says Tampa, down there working away in the colo facility, and you call me from Clearwater Beach, and you say, hey, Ryan, we wanted to go out to Disney World today. And I say, okay, Disney World's over here in Kissimmee, just outside of Orlando. It's about an hour away. Well, that's me reporting it from Tampa. I say it takes an hour to get to Kissimmee. The problem is getting from Clearwater Beach, where you're located, there's a lot of stoplights. And it's going to take you a while to get to downtown Tampa. It might take you 40 minutes. So your calculations would have to include the distance to Tampa. And Eric says, yay for Frenchie's Rockaway Grill. Can we check that out right now? I mean, it is Friday. Frenchie's Rockaway Grill. This is the best place. You're going to learn a lot in this class. If you ever come to Florida, if you ever come to Tampa, you got to come to Frenchie's. And they've actually got Where is it? Photoshop, calendar. I swore they had a live webcam. And let's allow site look. I'm not sure if I need that or not. But yeah, this is the place, man. They've got their own boats. They catch their own fish. And Frenchie's Rockaway Grill, that's my spot. Look at this, live webcams. And I can show it to you guys once I turn all this Java on. This is just adding to my story. I'm just trying to paint a picture. So here they are. We've got the bar. We've got the beach here. Not really quite going yet, but it's 5 o'clock somewhere. It's actually 6:15 here. So here you are. You're at Frenchie's Rockaway Grill. Excellent place to come visit. And you're asking me, okay, so how long is it going to take to get to Orlando? I go, well, based where I am, it's going to take an hour. It's going to take you 45 minutes to get from Frenchie's Rockaway Grill to downtown Tampa, and then another hour to go through Lakeland and go all the way to Kissimmee. You get the idea. So coming back to this, when someone reports a distance to you, they're not considering how long it takes to get to them. This is just the way the EIGRP math works. So the way that this works is we get advertised a distance, and then we have to consider what does it cost us to get to that neighbor. We add that, and then this gives us our metric. And then we compare our two different paths, and we go, okay, well, here's the 1011 network on the left. I can go this way, which is reporting a cost of $1,500, or I could go this way, which is cost of $1,000. Either way, it's going to cost me a $1,000 to reach my neighbor, which equals $2,000 or $2,500. $2,000 is the lower cost. This is the path that goes into my routing table. But should this path ever fail, we have a backup path. Is everybody okay with that? We've got a primary and a backup. Karen says, you're making us hungry. Yeah, I told that story because someone mentioned Frenchie's Rockaway Grill, and I've been thinking about buffalo grouper sandwiches ever since. I need to be thinking about successors and feasible successors, though. So what happens here is we've got two routes. You've got the successor route, which is our primary, and we've got a feasible successor, which is our secondary or backup. This secondary is going to be stored, and should this ever fail, we can move over to the feasible successor right away. This is why when they say, how fast does OSPF converge? They say it's fast. I go, how fast does EIGRP converge? And the answer is very fast. They don't really rate it in milliseconds because it's going to vary based on your environment. But EIGRP is so quick to converge because when we're calculating the route, if it's possible, if there's a backup route that's not going to be a loop, we can go ahead and just store that in case we ever need it. And if we need it, we can break it out and use it. So EIGRP uses two pieces of criteria to calculate the metric, bandwidth and delay. Optionally, EIGRP can also consider the reliability of the link. This is something that will get a penalty if it starts flapping. Like if it goes up and down, we go, that link's not very reliable, and we'll consider that when making a path selection. Additionally, you can take a look at load. So for instance, when you look at an interface, the interface may have a load value. Well, we can consider load when we calculate the route. This sounded super exciting to me, right? Doesn't it to you? I mean, don't you want to be like a super duper network engineer and be able to configure your network to make the best decisions ever? So I was like, okay, by default, EIGRP just uses 2. But if I learn to do this right, I can add 2 more and I can have the best decisions ever. I can have the most optimal network. And then I went to Cisco Live and I sat the EIGRP talk, and it was given by a guy named Don Slice, who's one of the main developers for EIGRP. And he explained why you don't want to actually use these and why they shut it off. And basically the load could change so much and so frequently that you wind up constantly doing recalculations, and you're doing a ton of hits against your CPU, and the decisions that you're making aren't really changing. So you can influence the path in different ways. We can manually manipulate this, but the overhead really isn't worth it. So a bit of a spoiler. I remember seeing this the first time I learned EIGRP, like in the late 90s. I couldn't wait to turn these on. And then I heard about it in CCNP, and I was like, gosh, I've got to find a customer that I can tweak and turn this on for. And then I went to Cisco Live, and they're like, yeah, we don't recommend that you turn this on. So we use bandwidth and delay, which is still smarter than other routing protocols out there. It's smarter than BGP. It's smarter than OSPF. It's a lot smarter than RIP. BGP's got more nerd knobs. It looks like almost like an airplane cockpit if you wanted to look at how to control it. But out of the box, this is really, really smart, and we don't have to touch anything. We don't have to tweak or tune anything. If you do a show interface, you may have noticed that you've got things like the MTU here, that you've got bandwidth. When you go into a router's interface, you can use a bandwidth command. Back when I was a baby network engineer, before I had my CCNA and I was setting up Cisco routers, I really thought the bandwidth command set the bandwidth. I thought this was a way to rate limit an interface. So I was running around changing these, thinking it made a difference. This doesn't have anything to do. You can set it by hand. Like on a serial interface, it assumes it's 1.544 megabits per second. If it's a fractional T1, I might drop the bandwidth down and say 384K. This doesn't rate limit the interface. It just tells the routing protocol what the bandwidth is on the link. And this is what OSPF or EIGRP would look at when determining what the best path is. You also see you've got things like the receive load, the transmit load, the reliability. The reliability will be 255 at 255 so long as it's up, but if it starts bouncing or flapping, going up and down, that reliability would take a hit. The load, you see that shows us a utilization in 1/255. These are things that you could consider, but Cisco tells you not to bother. How hard is this to configure? Really, really easy. We say router EIGRP, and we specify a number. The number is the most important thing to keep your eye on. In OSPF, this didn't matter. It was a process ID, which is locally significant to the box. Inside of EIGRP, however, this number is an autonomous system number. Autonomous system is kind of a funny term. It refers to a group of routers under a single administrative domain. In other words, the routers that you control. You could have a big environment, and maybe you control everything in America, but in Europe, in the Middle East, there's a different administrator. And there's another group of administrators for Asia. So your company is global, but you have different administrators in each region. If so, you could set up each region as its own autonomous system. So this could be AS10, AS20, and AS30. When you want the routers to form an adjacency, they need to be in the same autonomous system. So we can do router EIGRP 100. This is the AS number, and it must match. It must match your neighbor if you want to form an adjacency. This is a process ID, so who cares? I suggest set that to 1 just to make guys like me, to make our lives easier, because we always put 1, and then sometimes we do it without thinking and create 2 processes, and then we have to chase our tails to figure out that we've got 2 processes running that aren't exchanging routes. But that process ID is locally significant. The AS number needs to match between your routers. As always, the network statement tells us where to run OSPF. This is not what gets advertised. You're putting any network interface card that's in the range of 172.16.10 into the EIGRP process. Remember, this is a range, which I think is confusing as all get out. So what do? I put the IP address of the interface, and I put a /32 wildcard mask typically, which just looks like 0000, following the IP address that's on the interface. So in this case, I put 192.168.1.1 with the wildcard mask of all zeros. Over here, I'd say network 192.168.1.2 with the mask of all zeros. Does that make sense? I spent a lot of time in ICND 1 going over the network mask, or the network statement, just hoping that everybody can take that in. This is something that I didn't properly understand for, I don't know, my first 6 or 7 years as a network engineer. The network statement. How sad is that? I used it and it worked, and I had adjacencies and customers were happy, but I didn't really understand what it was doing. I believe that when I typed 172.16.1.0 and I would make the mask match the interface mask. And I thought this had to do with what I was advertising to other routers. And it's not. It's telling us where the EIGRP process will run. So I think it makes the most sense just to use an interface IP with a /32, unless you wanted to be fancy and put lots of interfaces all into the EIGRP process with a single command. Otherwise, I would use /32s. Once it's enabled on an interface, you should get EIGRP neighbors pretty quick. We can do a show IP EIGRP neighbors and see that they're there. We can see the interface that we discovered the neighbor on. We can see how long they've been neighbors. Additionally, this is just showing you the other side. We can do a show IP EIGRP interfaces, and we can see which interfaces are running the EIGRP process on. So just another good step in troubleshooting. If you don't have neighbors, are you running it on the right interface? If not, let's check out our network statements and make sure that we're doing it. Once you start to learn EIGRP routes, they're going to show up with a D. The letter E in the legend was reserved for EGP, which was BGP's predecessor. So they used the letter D. It might be because the algorithm used by EIGRP is called dual. So this is the actual calculations that are done in the background. And then also one of the main authors was Don Slice. It could stand for him. But basically E was in use, so your EIGRP routes are going to show up as a D. Here we see the administrative distance, and there you see your metric. Here we see our next hop. That's the interface we'll go out of. Pretty easy, right? Show EIGRP topology. The only thing that could be confusing about this for you is this shows us the network statements that we've learned. And then here we can see that those routes or those prefixes are passive. Passive is actually good. Most people look at this and they think they want to see active. Active is bad. This means we lost the route and we're trying to find a new route. We're trying to rediscover, so we're actively looking. Passive is what we want to see. It means that everything is converged and we have an optimal path to get somewhere. So EIGRP can do two types of load balancing. This is another thing that I learned as a young duckling, kind of making my way through networking. And it was like, oh, wow, another thing that makes EIGRP special is it can do unequal load cost balancing. In other words, I could have a connection to Verizon, and it is 3 T1 links. And I could have a connection to Cogent. So this is Verizon, this is Cogent, and it could be 1 T1 link. And I go, well, both of them get me to the internet. That Cogent link is my failover, but I could use both paths, so why not? By default, it's not turned on, and most people don't use it, but you can have unequal load cost balancing that allows you to send some packets, and I'll say most packets over one link, and some packets over an alternate link. And they say you can have a poorer link that's up to 128 times worse. In other words, this would look 3 times more desirable. I could have a path that looked 128 times more desirable and still use my backup path. This was something that I got excited about, but then ultimately looked at a lot of best practices and found out that this typically isn't used either. But that doesn't mean that you can't deem it worthy. You might see an environment where this makes sense to you to use. If you've got a 10 gig path and an 8 gig path, hey, why not? It can do unequal load cost balancing, where all routing protocols can do equal cost load balancing. All right, so that's going to be our summary on EIGRP before we get to looking at troubleshooting it. So troubleshooting, we can do show IP EIGRP neighbors to see that we have neighbors, and we should. If we don't for some reason, we can do a show IP interfaces brief and make sure that the process is running on interfaces. These commands kind of complement, I don't know if they complement, I'd say they either one could be used in place. They're going to let us see that EIGRP is running on an interface. The cool thing that, show IP protocols is going to show us the same thing as show EIGRP interfaces, except this will show us other protocols. Show IP interface brief is just going to show us our IP addresses. I had a bit of a brain fart there. Why is it typically not used in practice? Because of the way that the load balancing works, some devices will do a per packet load balancing. So you've got part of your flows going over one link with lower latency and other packets of that same flow going over a higher link. What you would need is per destination load balancing so that only particular flows go across that link. And you could actually handle it with something called policy-based routing. And that tends to be a little bit more popular. PBR is outside the scope of CCNA, so don't let it scare you though. This just means we're going to use an access list to make a routing decision. What do I mean by that? Well, normally a routing decision is simply made based on the destination IP. Look at the destination IP, look at the routing table, route the packet. With policy-based routing, I can use an access list, and I can match on an application, I can match on source, I can match on protocol, I can match on port number, I can match on time of day, and I can steer certain traffic over a particular link. So you can use policy-based routing and say, okay, well, all the YouTube traffic is going to cross this other link. Or all of our email goes over that link, or all of our DNS traffic goes over that link. And if the link fails, it switches over to the primary. So this gives us a little bit more control so I could steer a particular application over it. And that's a pretty good way to get use of multiple links. Yeah, no problem. So those are some of our components: show IP route, EIGRP, and here we don't see any EIGRP routes. So next step to do would be to look at our interfaces. Show IP interface brief shows us IP addressing, and of course shows us that our interfaces are up and up. So all of this looks healthy. He goes, why don't I have an he says serial 00 is up and up, it's got an IP address, why don't I have a neighbor? We can do show IP protocols, and it'll show us what routing protocols are running. And here he says, HQ is not my EIGRP neighbor. Could there potentially be a mismatch? Well, looking at the branch router, we see that EIGRP has an AS of 1. Over here on headquarters, we see that it has an AS number of 2. That's included in the multicast hellos that you send out. He goes, I'm an AS1, and this guy says, I'm an AS2, and they basically ignore each other. So in this scenario, we just have a problem where we've got the wrong AS number. We'd come to this router and say, no router EIGRP2, and then say router EIGRP1, add a network statement of 192.168.1.2 with a /32 wildcard mask, and watch our adjacency form. You can also do a show IP EIGRP interfaces. It'll show you which interfaces have it enabled, and it also lets us double check that AS number. And show IP protocols is another useful command. It's going to show you all routing protocols that are running. So if you do something where you create 2 instances on accident or 2 different ASs, you'll catch it because they'll be listed separately. Additionally, we can see passive interface. Does anybody remember what passive interface means from ICND1? If I do a show IP protocols and it says passive interface serial 00, what effect would that have? And let me see if I can refresh your memory. I said I might use this in OSPF if I've got an interface here that's DMZ. So over here is the internet. I've got the DMZ. I've got the inside. And I said one of my DMZ servers, like the web server, DNS server, mail server, FTP server, could get compromised. And Eric says you're advertising EIGRP out that interface. Right. So what passive interface says is I want to advertise the DMZ network to other people. So tell them about it. That's what our network statement does. But I do not want to send hellos out that interface. So passive interface says no hellos. In other words, advertise it, advertise the whatever this is, 192.168.1.1 network to other people in 10. Let them know it's over here, but there's no hellos being sent. If there's no hellos being sent, we can't form a neighbor adjacency. So we need to do a no passive interface on serial 00. All right. So other things we could look for, there's something we haven't really talked about called filter lists. Think of an ACL and realize an ACL's permit and deny statements with network addresses and subnet masks. A filter list is basically an ACL that can permit or deny route advertisements. So if I've got the 10110 network over here, and this is a company that we just acquired, and they also have 10110 over there, IP address overlap happens pretty regularly, I could create a filter that says, go ahead and form an adjacency with that guy. But if he tries to tell you about 10110, don't believe him, because we've got the 10110 we want over here. So we can use filter lists to allow or deny certain networks to be advertised to other neighbors. Typically, you don't need this. In a perfect world, we want everything to know how to get everywhere. But in the event that we want to prohibit particular routing information from being learned and then allow others to be learned, you can use a filter list to do that. Outside the scope of CCNA, but still not bad to know about, because you might encounter it in the real world. Another problem that could get you into trouble is the auto summary. EIGRP performs auto summary many times by default. What that means is if you're on a classful boundary, that's what's happening here. He's got 172.16 addressing on one interface and 10 addressing on the other interface. What your router's doing here is he says, you're a smart guy or girl. You would never create an environment that was completely unhierarchical. In other words, you would never put 172.16.1 over there and 172.16.2 over there. It would be miserable to try to perform summarization, and we know that. So if you ever jump from a 172 address to like a 10 address, we're just going to go ahead and say 172.16.00/16. In other words, we're going to use a class B mask and automatically summarize this for you, so that you tell router B 172.16.00/16 is over here. The problem is this router is going to do the same thing. He's going to tell router B 172.16.00 is over here. So the path with the lower metric is going to win. And if the metrics were the same, you could wind up with half your packets going this way and half your packets going the other way. So automatic summarization is typically a pretty bad idea. This is why we say no auto summary. So it just advertises this network with the exact mask. All right, and you would do that with the router EIGRP no auto summary. Real quick, let's just do a demonstration of how bad this would be to set up. And while I'm bringing this up and configuring it, please let me know if you've got any questions. Let's go ahead and bring up the last topology that I used, which was a bunch of routers doing OSPF, and we'll rip out our OSPF config. All right, so there's my topology. We're going to get rid of the concept of area 0 for now. Delete this. There we go. And area 1. Those concepts don't really matter in EIGRP. But we'll say our topology looks something like this. We can start all the routers, and we'll see them come up with little green lights as they go. That's our progress indicator. And we can bring up a console port here in a second once they all boot. All right, looks like everything's doing pretty good. They're all turned on. Let's go ahead and open up some console sessions. Now, this is me using GNS3. This is great once you've got your certifications and you just want to mess around. By all means, use this. Until you get your CCNA, I'd really, or even if you're working on CCNP, if you're working on certification, I'd probably stick to NetSim because it can grade your configs. They've got a lab book. It was a little bit better thought out, I think. Looking at our topology, I can do a show IP protocols, and I see that I've got OSPF running. So I'm going to say no router OSPF 1, and it's gone. Now, to bring up EIGRP, router EIGRP, and I'll just create my AS number as 10. And I can say network, and watch what I do here. I'm going to say 0000 with a wildcard mask of 255, 255, 255, which would be like, actually, I think I want, yeah, that. And then I can say enter. This should start EIGRP on every interface. Now, if I look back at my topology diagram, R1 is located here. Let's go ahead and bring it up on R2 and see if we can get an adjacency. So coming over to R2, show IP protocols. We should have some OSPF. We can get rid of it. Router OSPF 1, and let me do no. And then just do router EIGRP 10. Remember, that must match. And network. That should put all my interfaces in EIGRP, and immediately I got a neighbor relationship. I got one on FA00 and one on FA01. If I come back and look at this, I was on R2, so FA00 is up there. It means I just formed an adjacency with R3. R3 must have already had EIGRP, and I must have picked AS number 10 last time. Show IP protocols. And I just so happened to pick EIGRP 10 last time. And if I do show IP route, we should have some EIGRP routes designated with a D. So there we see 1099.12.0, 10.201. Now, EIGRP will try to do auto summary. So a lot of times what we'll do is when we go into EIGRP, we say no auto. And it'll tear down and rebuild the adjacency real quick. And we can make sure that that never bites us. Show IP route. And again, we see our EIGRP routes. Not terrible to configure, huh? We see the administrative distance of 90. We see our metric here, which is a little bit uglier than OSPF, but it's thinking about a little bit more. And that's all there really is to it. Any questions at all? That's going to wrap us up for today. And I'll show you EIGRP with IPv6 on Monday. I want to give you guys a little bit of time to forget some things. And then we'll jump back in and look at EIGRP on v6. All right. Well, it doesn't look like I've got any questions pouring in. Last question for you guys. Is everybody having a good time? That's important. Seriously, I hope everybody's having a good time. I hope the class is fast-paced enough that you're not bored, but I hope that it's not too quick so I'm not losing people. So if I am, just let me know. I can go over anything if I move too fast. If I'm not moving fast enough, send me a private message. Tell me to get going. Other than that, that's it for week 1. I hope this has been a good week for you. I hope you're learning lots of good things, and I look forward to seeing everybody on Monday. Have a rad weekend, and as always, if you're typing out a message, I'll stick around for a couple minutes so that I don't miss you, and I can stick around and answer anything afterwards. Otherwise, have a great weekend, and I'll see you on Monday.